Testing, testing, new headset. Larger than the other one, so hopefully it works and captures more sound, including y'all's reactions to the problems. Like, eek, ay, oh, right? Like a melodrama. All right, what do y'all think of H then? That says FOF, right? FOF. We are in the process of composing. How do we really read that? Not FOF, but what? F of X. Now, let's give this guy a new name so we don't have to refer to him as FOF. What do you want to call him? What letter of the alphabet have we not used yet? No, we used Z yesterday. T. Okay. T for Texas. Hook 'em horns. T of X is the formal display only version is this, right? F of X. The blue color version is F of X. And that's the one that I like. I prefer that you write it like that because now you can physically see that F is supplanting X into the function F itself. So we start with the outside function, F. F is 1 over X minus 3. But what am I putting, first of all, in place of X? I'm putting parentheses first. And then inside that parentheses, I'm putting F of X, which is 1 over X minus 3. This problem's so meta, right? It's inside of itself. Look at that. Okay, now I need to find the domain before I simplify. This is a complex fraction. If you want to rewrite it without the parentheses, it would look something like this. All right, let's go ahead and talk about the domain. We have two domains to consider here, or two denominators to consider. We have the miniature denominator, which is this guy right here, and then we have the overall larger denominator, which is 1 over X minus 3 minus 3. So what value for sure do we know won't work in the miniature denominator? Positive 3 won't work. So let's come off to the side here and just put comma. X can't be 3. We know that. Now for the other one, we might need to do a little bit more work. Let's think about the other one here. 1 over X minus 3 minus 3 shall not be 0. Shall not be 0. Can I solve that for X? Yes. Let us bring the 3 to the other side. And then y'all learned back in the day that you can cross multiply, right? If you put that over 1, you can cross multiply. So you get 1 over 1 times 1 is 1, shall not equal 3 times the quantity X minus 3. That's cross multiply. Cross multiply. Remember, a non-equation like this is equivalent to an equation. And now if I just distribute, I get 1 cannot equal 3x minus 9. Add 9 to both sides, and I get 10 cannot equal 3x. And I solve for x, and I get x cannot equal 10 thirds. Let's see if that's right. Let's plug it back in. Bless you. Let's plug it back in. What is 10 thirds minus 3? Well, 3 is how many thirds? 9 thirds? It's 1 third, right? So 10 thirds minus 3 is 1 third. What's 1 over 1 third? 1 over 1 third is 1 over 1 third. Stay, change, flip. It's what? 3. Yeah, it's the reciprocal of a third. What's 3 minus 3? 0. Does 10 thirds cause a 0 in the denominator? Yeah. All right, so now we package it back up here. We'll say the domain of, what do we call them? T, Texas, right? D of T is the set of all x such that x is not equal to 3 nor 10 thirds. Now, I want you to do one other thing. Bring this back down here. Do you remember when we were simplifying complex fractions back in the day? Oh, yeah, we do.
Hi, good morning, and
Hi.
sorry for the interruption.
No worries.
We are looking for 2 students for the art field trip, Raina Stratton and Cheyenne Murphy. If you are here on campus, please meet Mrs. Blank by the back van doors. Thank you.
Do you remember how we quickly and effectively and efficiently cleaned up complex fractions back in the day? We did lick 'em over lick 'em, the LCM over the LCM of your miniature denominators. Our miniature denominator is x minus 3. So I'm going to put an, oh, easy there with the highlighter, man. X minus 3 over x minus 3. Remember we were destroying bunk beds? Remember that analogy? We're bunk bed destroyers. We have an upstairs, and now we have a bunk bed of x minus 3 over 1. We have a downstairs with a bunk bed of x minus 3 over 1. If I just multiply straight across from the top, 1 times x minus 3 is x minus 3. And the bottom, if I distribute the x minus 3 to both of them, I destroy the bunk bed in the first one, so I just get 1, and then I get minus 3 times x minus 3. Okay, remember doing that. We're distributing. All we're doing is distributing the x minus 3 quantity in the denominator to both terms. Everyone okay with what I just did there? Now, I can simplify a little bit more in the denominator. I can distribute the negative 3 to get negative 3x plus 9, and then I can combine the like terms, and I get x minus 3 over 10 minus 3x. That would be the simplified version of t of x. But remember, when you simplify, you possibly get rid of problems that were there originally in terms of domain. If you were to find the domain of t of x now after you simplified, you would say the denominator 10 minus 3x cannot be 0, and you would get x cannot equal 10 thirds. Well, we know that, right? But what other value is also not allowed? Positive 3, and we lost that because we oversimplified. So this would be where you would need to declare to the casual user, hey, you can use the simplified version of t of x for all of your needs, except, of course, at 10 thirds, which this one also prohibits that implicitly or explicitly, but you also can't use it at 3, which this one might allow you to do that, right? So we would need to tell people not to do that. It's all coming together. All the skills that we've been learning so far this year are coming together. We're becoming algebraically agile. That's the word I was looking for. There's that Swiss cheese moment right there. What word was I looking for? Hey, speaking of words, GOG. Is that a word in the English dictionary? No, but guess what is? Agog is a word in the English dictionary. Do you know what it means to be agog? Yeah, very good. Or bewildered with amazement. Yeah, like it's a good surprise. It's not like, oh, there's a lawsuit waiting for. Oh, you just get. It means surprised in a good way. Like if you're agog, you're kind of dizzy with surprise, bewildered and dizzy. Dizzy, I would say, with amazement. So like when you walk in and you see the math problems on the board, you become agog. You become agog. Right. All right. Now without the A there, we don't read it as gog, we read it as what? G of g of x. I'm going to call this one A of x for agog of x. And it's going to be g of x. That's the display only formal version. Looks pretty. The blue collar let's get to work version is g of x. So yes, we can plug one function into itself. No problem. No problem at all. We did it with f. We'll do it with g now. G is the square root. So working from the outside, it's the square root of blob. And the first thing I do in place of the blob is I put a parentheses. Okay. So again, what I'm doing at first is I'm doing the outside function. And then I come back on the inside and I put g of x in there, which, oh, by the way, g of x is that. Square root of x. Yeah, there it is. All right, now, of course, if I clean that up, the parentheses are there just to show the substitution. So now I have the square root of the square root of x. OMG. Okay, here we go. What values will work in the domain? Well, let's look at your miniature denominator right here. I know that x has to be greater than or equal to 0. Yes, yes? Yes, yes. That takes care of the little radicand. But I also have this whole thing is a radicand itself, isn't it? That has to be greater than or equal to 0. For what values is the square root of x greater than or equal to 0? Well, can we solve that one algebraically? Can I just square both sides? No. 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 We can only solve linear inequalities algebraically. Remember that? X to the first. And even then we have to remember not to forget, I feel like I'm speaking to them only. We have to remember not to forget that we have to flip the inequality when we multiply or divide by a negative, right? Is this a linear inequality? No, it's an x to the 1/2 inequality. It's the square root of x inequality. So just like we did with quadratics on the warm-up 2 days ago, we have to solve it, or yesterday, I guess, we have to solve it algebraically. Okay, do we know what the square root of x looks like? Yeah, it looks like this. Okay, for what values of x now is that graph greater than or equal to 0? That means that translates to on or above the x-axis. That's what greater than or equal to 0 means. For what values of x is the green graph on or above the x-axis? For all values of x that are what? Greater than or equal to 0. Ah, so do they have the same demands of each other? Yes. So it works out that I don't have to combine them by restricting them. I just say, oh, they both have the exact same requirements. So the domain of A, or A's domain, if we don't use the passive voice, is the set of all x such that x is greater than or equal to 0. Or if you like the interval notation, you could say x epsilon beefy bracket 0 to infinity parenthesis. X can equal 0. You want to try it? Let's try it out. If you plug in a 0 for x, you get the square root of 0, which is what? Is 0, right? And now I have the square root of 0 again. What's the square root of 0 again? 0. It works. Yeah, 0 works. Yeah. Now, hey, let's simplify this, shall we? Let's simplify this. This is the same as blob to the 1/2 and then inside x to the 1/2. Yes, yes? Remember, we want to find the domain before we simplify. Once we find the domain, now we're free to simplify. We like having rational exponents instead of radicals because it allows us to use the rules of exponents, which says what? How do we combine these? When you raise a power to a power, what do you do with the exponents? You multiply them. When do you add them? If it were x to the 1, highlighter. It's like a disease. If it were x to the 1/2 times x to the 1/2, that's x to the 1/2 plus 1/2. That's when you add. But when it's x to the 1/2 raised to the 1/2 power, it's x to the 1/2 times 1/2, which is x to the what? 1/4. And of course, if I put that back now in radical format, that becomes the 4th root of x. Yeah. And if I were to find the domain of the 4th root of x, since it's an even radical, I would just go off to the side and say, oh, x has to be greater than or equal to 0, and I'm done with the domain. So we don't really change the domain this time by simplifying. Nifty, right? Are y'all agog with wonder? Yeah. Drunken with wonder? Right? Dizzy with wonder, not drunk with wonder. That Celsius can sure looks like like one of those White Claws, you know? I've never seen it before, but it's not. It's not. Okay. Wow. Okay. Any questions on example 2? That takes care of H and I sure hope this new microphone is working. Yeah, the other one would just like fizzle out if I got too far from the computer desk. This one hopefully has a range of at least 20 feet maybe. All right, look at example 3. Fogo, fogo, foga. How do we actually read that? F of G of H. F of G of H. Are we allowed to compose 3 things? Yeah. Okay. Let's go ahead and give this guy a new name. What do you want to call F of G of H? Well, let's give it a new letter. What letter have we not used yet? B for Brock. I like it. B for Brock. Or Brody. Either one. Yeah, it looks like a Brock or a Brody. He looks like a Brady third. F of G of H of X. I'm sorry, it's not B. It's B of X equals F of G of H of X. Sorry. I was not thinking. Swiss cheese. I'll just say Swiss cheese. Every time I make a mistake, I'll just say Swiss cheese. And you know what I'm talking about, right? I'm not talking about cheese at all. I'm talking about my cerebellum. All right. How would we write that in blue collar form? Well, let's see. F of G of H of X. Close, close, close. Sounds like I'm describing my wife's closet, doesn't it? Close, close, close. 3 closets full of nothing to wear. F of G of H of X. There it is. Okay, so this one has the H function plugged inside the G function. And then that result itself is plugged into the f function. Yeah? What a spiffy day it is. So for this one, I would recommend either trying to do it in one big bite or in smaller bites. What would you suggest? Good, smaller bites. We don't want to choke. Okay, so let's come up to the side here and look at, highlighter. Let's just look at g of h of x. We have the two system mastered, don't we? Let's go ahead and see what that gives us. I'm starting with the outer function g, which is blob to the 20th power. And what am I plugging in for the blob? I'm plugging in h, which is x plus 5. So now I have x plus 5 to the 20th power. That's what I need to plug into f. So what is f? Well, f is blob all over blob plus 1. And what am I plugging into both of those parentheses? X plus 5 to the 20th. X plus 5 to the 20th. X plus 5 to the 20th. There we go. See? It's fun easy. Now the purple parentheses show the replacement of x with the receptacle. Now I can simplify it. I don't need all those parentheses. I can just say it's x plus 5 to the 20th all over x plus 5 to the 20th plus 1. All right. What am I supposed to be doing? It says just to find it. Did I find it? I did. Let's go ahead and go one step further because we're all about going above and beyond, aren't we? Let's go ahead and find the domain of b. D sub b, okay? Well, I'm going to do the work over here. I don't have a radical, do I? All I have is the denominator. So the entire denominator, x plus 5 to the 20th plus 1, shall not equal 0. Shall not equal 0. Now, let's solve. It's an equation. So x plus 5 to the 20th shall not equal negative 1. Stop right there and think. Think. You don't want to have to possibly get extraneous solutions. Is it possible to take a quantity, x plus 5, which could be positive, negative, or 0, raise it to the 20th power, which is an even power, and get a negative number? No. This over here is always positive, and this over here is always negative. Is that possible? No. So are there any restrictions? Are there any x values that will make this happen? No. So there's no restrictions, which means the domain is all real numbers. Very good. So D sub B is double bar R. Yeah. Now, if that had been to like the 19th power or an odd power, now there's a possibility of getting a negative, okay? A negative on the left side. So we would have some restrictions, but not in this case. Okay. See, that wasn't too bad, right? Inch by inch, it's a cinch. Mile by mile, it's a trial. How do we eat the elephant? In one big bite? No, we don't eat the elephant inch by inch. Yeah, we get there inch by inch, and it's a cinch, but we eat the elephant one bite at a time. One small, delicious bite at a time. Okay? You take a bite of the elephant, and you go, elephant. Kind of a lot like math, actually. Yeah, it's got a really bad math aftertaste. Yeah. Okay. Any questions on example 3? Did I? Where is he?
He was there.
Mr. Hughes was in here? Oh, no, I didn't even know he came in. No.
You were just like, what did you do? Like, oh, I want him. And you're like, that Celsius camera looks like a White Claw over there.
While he was in here?
Yes.
Oh, yeah. Okay. Yeah. Well, cool. I'm glad he heard that. He needs to get those things removed from the vending machines. Yeah. No, I didn't even know he was in here.
He was pretty quiet. I didn't realize it.
He's sneaky.
He snuck in.
He is a sneaky dude.
I just saw him.
Yeah, I had. Yeah. Okay. All right.
He turned like slowly shut the door and then he sat when he left he like slowly.
He's going to make a comment that I need to be more aware of my surroundings because he could have been a threat to the classroom, and I would have just been like, "Come on in, shooter!" Right? But he had a key. He had a key. Yeah. So shame on him for violating our sanctuary. Yeah. No, he's welcome in anytime. He's the boss. He's the principal. But we do need to do something about those Celsius cans in the vending machines. They need to change the label or something. Make them look more like soda pop instead of like alcoholic cans. Yeah. All right. Um, I said that looks like a White Claw when he was standing right behind me. Okay. All right. Good. Good to know. All right. Example 4. If F, he was probably agog when I said that, right? Yeah. I hope I'm here tomorrow, guys. I hope I'm still here tomorrow. All right, example 4. If f of x is equal to that and h of x is equal to that, it says to evaluate and simplify the following. Okay, f of negative 2, f of negative 2. So here's what we're going to do for f of negative 2. I'm just going to work straight down without an equal sign. F of negative 2, well, f says to take your input and go 3 input squared plus 2 input minus 4. See what I did there? What was the first thing that I did? I replaced x with what? Parentheses, with receptacles, right? With bubbles, whatever. And then, because there is a negative 2 there, I'm going to put a negative 2 there and a negative 2 there. That is going to guarantee that you get the setup correct, yes? It's going to guarantee it. This is not on your notes? Holy moly smokers. Did you get yours from the internet or from the Canvas course? Get it from the Canvas course. Sorry. I did a little switch. I changed it up. So sorry. Yeah, just add the notes from the Canvas course to the end of the notes that you got from the internet. I apologize for that. He was standing right behind me. Didn't even say anything.
I wanted to say something, but I didn't want to like make it a big deal.
No, it's not a big deal at all. I don't care. Was I talking about my Swiss cheese brain too?
Yeah.
Okay, good. Yeah. He's going to reassign me. I'll have mop duty. Yeah. All right. Everyone good now? Okay. So we put parentheses where there's an x and we plug in a negative 2. All right. Now I have to use my dear Aunt Sally's rules to simplify this. This is going to be 3 times negative 2 quantity squared is 4. 2 times negative 2 is minus 4. And then we got the minus 4 hanging out there. We have 12 minus 4 minus 4. So that's actually, if we go from left to right, right to left, does it matter? Not as long as we consider those last two numbers to be negative 4s. You can do 12 minus 8 if you want, and 12 minus 8 is 4. That's fine. If you think of them as all add-ins instead of subtract-ins, you can add them in any order you want because it's commutative. But the numbers are negative 4 and negative 4. Okay, so there you go. That was not a big deal. So now what is h of f of x? Well, h of f of x. We're starting on the outside with h. So h of blob. Let's see what h of blob is. It's going to be 5 minus 4 times the blob. 5 minus 4 times the blob. And what am I going to plug into the blob? I'm plugging in 3x squared plus 2x minus 4. 3x squared plus 2x minus 4. Okay, now I'm going to simplify that. All I have to do is distribute the negative 4 all the way through, and I get 5 minus 12x squared minus 8x plus 16. And now let's go ahead and simplify by writing the terms in descending order and combining like terms. So I get negative 12x squared minus 8x, and then 5 minus 16 is negative.
Why would you subtract 5?
Oh, why would I subtract 5? Swiss cheese. 21. Plus, it should be plus. Yeah. There we go. Yeah, that's it. What would be the domain of this? All real numbers. Very good, because it's just a quadratic, right? It's a polynomial. We're going to study polynomials in the next section, but it's quadratic. Its graph would be a parabola. Okay. More of the same. More of the same. We're going to get really good at composition. Look at part C. F of h of x, when f is that and h is that. Okay. This is the fancy display-only version. Yes, yes? So let's go ahead and write it in the blue collar, let's use it version. F of h of x. Now I can clearly see that I've got h of x sitting inside f of x. So what's that going to look like? Well, f again is, highlighter. It's 3 blob squared plus 2 blob minus 4. 3 blob squared plus 2 blob minus 4. And then I'm plugging into there h of x. So that's 5 minus 4x, 5 minus 4x. These make good questions on free response questions on tests. Have you set it up and then simplify it. All right, so now that I have plugged in the 5 minus 4x in for x into the f function, now I can simplify. Let's see as an honors class if we can square, multiply, double square, and distribute the 3 at the same time. You think we can? Yes, we can. Do you think we can do it?
Yeah.
Uh-huh. I want to say, uh-huh. Uh-huh. Yeah, okay. Where's Hughes now? Boy, that was, you can see me inspiring confidence in y'all. Square, multiply double, square, right? That's how we square a binomial. And distribute a 3 as we write it down. So here we go. Square the first, 5 squared is 25. 25 times 3? 75. Okay, good. For the middle term, we multiply and double. What's 5 times negative 4x? Negative 20x. We double that to get negative 40x. Now we have negative 40x. We triple it to get negative 120x. Yeah, there you go. Multiply double, and then multiply by 3. And then you square the last. What's negative 4x times negative 4x? 16x squared. And 16 times 3? 48x squared. Okay, there you go. Is it okay to go off to the side and say 16 times 3 like this if you need to? Yeah, that's perfectly fine. It's perfectly fine. But we're saving a whole line of writing by distributing the 3 as we go. Now over here, there's no squared on the outside, so we just distribute. We get plus 10 minus 8x and then minus 4. And now we combine like terms, writing it in descending order. So we have a lot of terms, so sometimes it's nice to be organized, so I'll underline them as I go. I have one x squared term, so it's 48x squared. I've got 2 x terms, so minus 120 minus 8 is minus 128x. And then let's see, all the ones that are left are constants. So from left to right, 75 plus 10 is 85. 85 minus 4 is 81. Yeah. And what would be the domain of this function? All reals. It's another quadratic. Yeah. So this is just basically, do you know how to set up a composition of functions? And do you know how to use the sledgehammer method? This is what I call the sledgehammer method. We're just expanding it out, right? We're taking something like this and we're expanding it. It's like hitting it with the sledgehammer and it's falling into its smaller pieces. It's just expansion, okay? Does it take a lot of skills to use the sledgehammer? Anyone ever bought a sledgehammer, like new? Is there an instructional booklet that comes with it? No, right? Because you don't need an instructional booklet, right? You just start swinging it. And if you hear this sound, you're holding the wrong end, right? You got to hold the wooden end and swing the metal end, right, to do some damage. That's all we're doing here, right? Okay. Yeah. Oh, holy moly smokers. What does this mean? Well, let's come off to the side and make this note. If you see something like this, f squared of x, that's the same thing as f of x quantity squared. This side over here is the display version, and this is the use version. When we square it like that, we read it as f squared of x, but it's really f of x, the quantity squared. We're not squaring the input, we're squaring the output, okay? So let's go ahead and write this in blue collar form. H of f of negative 1 quantity squared. Now, because this one has a number on the inside, instead of plain old x, you can actually do this one as a sequence of, do this one as a sequence of operations. Because we have a number, not an x. So let's see, what is f of negative 1? Let's go off to the side. What is f of negative 1? Well, f is 3x squared, so again, I'll go 3 parentheses squared plus 2 parentheses minus 4. Then I'll plug a negative 1 in there. And now if I simplify that, I get 3 minus 2 minus 4. which is -3. Well, no, I'm only doing f of -1 first. Now that I have my -3, what is f of -1 quantity squared? Well, that's going to be -3 quantity squared, which comes out to be what? 9. So over here, this really turns into just h of 9. Everything on the right-hand side here, that's my workbench. H of 9. Okay, now, how do I find h of 9? Well, I plug it in. H is 5 minus 4 blob. So I put parentheses where there used to be an x. I do it every time. And what am I plugging in for the parentheses there? A 9. So now I get 5 minus 36, which is -31. That makes a great multiple choice question as well. So whenever you have a number on the inside, you could just work from the inside out using your Dear Aunt Sally's rules, parentheses first. Okay? And if it's an x, that means that we're actually plugging in to get a brand new function. Funkier funks from funks, right? That's kind of the title of this section. 2.5, funkier funks from funks. We're getting funky functions from other functions. That's very official. Oh, he was looking for the I will, we wills on the wall. Yeah. Did he take a picture of them? I think he squinted. Oh boy, that's not good. Y'all have to squint? I can read it from here. We will learn how to compose functions and find their inverses. I will compose and simplify two functions in any order, and I will verify if two functions are inverses by composing them. We haven't gotten to the second part yet, but we've done the first part, right? I will compose and simplify two functions in any order. Yeah. In fact, to give you a shot at I will, let's look at part E. How would you read that? H of H of H of X. Talk about inception, right? You're plugging a function into itself and then that back into itself. I would not try to eat the elephant here in one big bite. Let's focus on this part right here. Let's focus on off to the side. Let's focus, highlighter. Let's focus on H of X. Now, here's the I will part. You find H of X on your own. Simplify, find and simplify H of X. Once we find that, we'll plug that back into H itself. But we're going to eat the elephant one little small bite at a time. I'm going to do it up here with you, but quietly. You had the wrong, did different signs than I did. Who got it right? Did I get it right or you get it right? Where'd you make your mistake?
I forgot.
Oh, you forgot to distribute the negative. You just did the 4. Simple. Yeah, okay, good. Yeah. It's real easy to forget to distribute that negative to the second negative and just call it negative 16x instead of positive 16x. All right, so y'all completed your I will for the day. Everyone got -5 plus 16x or 16x minus 5? Okay, so that's the highlighted part over here. That's this highlighted part. So now I'm going to, someday I'll get it right. H of 16x minus 5. And notice I'm bringing that back into my project, right? Off to the side, I did H of X on my workbench. And then I'm bringing that back into the project, which is in the same vertical line as the original problem. Yes, yes? Yeah.
5 minus 20. That's -15.
Why did I put -5? I asked you if that was right. Y'all said yes. Yeah. See, there you go. Checks and balances, right? Checks and balances. Math is a democracy, isn't it? Not really. Not really. Okay, thank you. So it's 16x minus 15. We got that settled? Everyone good on that? Don't just say I'm right because you want an A in the class, right? You got to earn it. Now you bring that back into the project, right? Maybe this should actually be written more like that. And now I'll plug that into H. Well, what is H? H is 5 minus 4 Of blob, right. Get in the habit of calling X blob, and then wherever you say the word blob, you put parentheses so that you can put blob inside of it. Well, what am I putting inside of it? 16x minus 15. And guess what? We do it again. Now we distribute. We get 5 minus, bless you, what's 4 times 16? 64? Yeah. X. Is it okay to go off to the side and go 16 times 4? Yeah, it's perfectly fine to do that. Okay, so you get 64x plus, what's 4 times 15? 60. All right, and now in descending order, we get negative 64x plus 65. Do we all get the same answer? It's a democracy. It's a unanimous vote. Hey, did y'all hear they removed the Speaker of the House yesterday for the first time in the history of the United States? First time in the history of the United States.
What they removed?
The Speaker of the House.
Who's the name? McCarthy?
Well, McCarthy was, but yeah. Yeah.
Who's the new speaker?
The interim speaker is some other Republican. He's just an interim until they vote for one. Yeah. He's some guy with glasses. He looks like he's a little professor.
Well,
He he's just divisive. He's a divisive guy. He leans more towards the Trump kind of spectrum, the radical rights, the right radicals. And so there were several Republicans that voted with the Democrats, switched sides to remove him. So first time ever. Anyway, that's what democracy is all about, though, right? Majority wins. Majority wins. Just like in math, right? Majority wins. I got outvoted. 16x minus 5. That was just a single vote. Everyone else voted 16x minus 15, so that's what it is. Because that's how math works, right? All right. Let's do this one and we'll call it a day. What do you say? Yeah. F of x plus a minus f of x over a. OMG. Do you recognize that?
yeah. Yes.
You totally recognize that because that is my favorite problem. Yeah, let's set it up and evaluate it. So we're going to get in the top, f of x plus a. That's going to be 3 blob squared plus 2 blob minus 4. There's the first one. Okay, and what am I going to plug in to the parentheses? I'm plugging in an x plus a right there. So I get x plus a. Ah! I had too many Celsius this morning. X plus a, x plus a. It's an energy drink, you say? Okay, so it's like Red Bull.
Yeah.
Oh, okay, okay. I've never seen those before. Minus f of x, which is just the function itself. So 3x squared plus 2x minus 4. All over a. So there it is. There's the setup. If you don't have the setup, guess what? Guess what's going to happen after this if you don't have the setup correct? You're gonna yeah, pretty much. We're plugging in x plus a, so it's there twice. And here's the other common error. People forget to put this bracket or a parenthesis around the second term because that negative is going to ultimately have to be whatted? Distributed. Yeah, and a lot of people miss that. And they're like, why are things not canceling? Why is everything doubling? And they don't figure it out. Okay. Now let's square, multiply, double square, and distribute a 3 again at the same time. You ready? X squared is x squared times 3 is 3x squared. Multiply and double, you get 2ax times 3 is 6ax. And you square the last a squared times the 3 is 3a squared. So that's square, multiply, double square, and multiplying through by 3 all in one. We're pretty efficient. Now we distribute the 2 plus 2x plus 2a minus 4. And then we distribute the negative minus 3x squared minus 2x plus 4 all over a. And here's your checkpoint, right? If you set it up correctly and expanded it correctly, everything in this case without an a should cancel from the top. 3x squared minus 3x squared. Plus 2x minus 2x. If you end up with a positive 4x there, you're doubling it instead of canceling. You didn't distribute the negative. Negative 4a plus 4, those go to 0. If you end up with a negative 8, you doubled it instead of canceling it. You forgot to distribute. Now there's 3 terms left in the top, yes? And all 3 of those terms have a what in them? An a. So we show this step. We factor out without a highlighter. We factor out an a, and that leaves us 16x plus 3a plus 2 all over a. And here's the most gratifying part of the whole problem. What happens with the a's? They what? They divide out. And we get 16x plus 3a plus 2. Oh! Democracy. Yeah, it is. I was looking at the plus sign, the vertical bar of the plus sign, and I read that as a 1. Instead of reading it as a T, which it actually is, I disregarded the horizontal line and just took the vertical line, and my brain saw a 16. Swiss cheese. Y'all are in good hands, aren't y'all? Yeah. Okay. Hey, but together, we keep each other accountable, right? I just happen to be the one that grades your tests. Yeah. All right. We're done with page 3. We will go forward after this, starting tomorrow. And are we ready for a quiz tomorrow? We should be ready for a quiz tomorrow with my favorite problem on it, and maybe an F of X or a GOG. How about a GUGOG, a GOGOG? What if I have you do G of X? GOGOG. Be ready for a quiz and be disappointed if we don't have one, okay? And I hope the microphone works.